All right, good morning, ladies and gentlemen. So today we are going to be working on Lewis structures again. It's going to be a little bit easier than what I taught you before. I taught you the more complicated way last time to help you with how electrons are bonding. And this time, I'm going to take for granted that you know how the electrons bond, and we're going to get into some shortcuts with Lewis dot structures. So a couple of reminders. Each atom wants to have 8 valence electrons. Remember, the valence electrons go around the outside. This group here has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons respectively. And with that, hydrogen only wants to have 2, whereas all the other elements want to have 8 until I tell you differently. So a couple of things you need to do. Number one, you count the total number of valence electrons for the entire molecule. Okay. Next, ladies and gentlemen, you want to draw the skeleton, which I'll take you through. Then you're going to subtract out the electrons that have been bonded, and then you distribute the leftover electrons. So let's just go through this quickly, and I'll show you what we have. So here we go. So we have water. First thing we do, count the valence electrons. There is H2. Each hydrogen has 1 valence electron, but there's 2 hydrogens, which means you have 2 valence electrons. Oxygen has 1, 2, 3, 4, 5, 6 valence electrons. So we have 6 valence electrons. So the total number of valence electrons, we have 8 valence electrons. And now what we want to do, that V is a valence, that's an E for electron. Now what we want to do is we want to draw out the skeleton. Now we know that the one that there's least of almost always is going to go in the middle, all right? And the ones that are less electronegative, okay, the ones that are further to the top and further over, or more electronegative, the ones that are further to the top and further to the right, those are going to be more on the outside. So let's draw a stick figure for water. We're going to put oxygen in the middle, and then we're going to put a hydrogen and a hydrogen. Now we have 8 valence electrons. Boom, count the valence electrons. Draw the skeleton. Boom, we drew a skeleton. We know the hydrogens have to bond to the oxygens, right? Now we want to subtract the amount of electrons that we've used in the bonds. How many electrons have we used in the bonds so far? Well, remember, there's an electron there, an electron there. Each bond holds 2 electrons. So how many electrons have we used so far? So far, we've used 4 electrons. So we're going to subtract those. We've used 4 bonded electrons, right? And if we subtract 8 minus 4, that leaves us with 4 electrons. And now we're going to distribute these electrons over all the atoms, but we're going to start on the outside atoms first. So we have 4 electrons to distribute, and we're going to say, well, how many electrons do I need? Well, hydrogen needs 2, and it has 2. This hydrogen has 2, and it needs 2. So I'm not going to put any on the outside. Now what we're going to do is take those 4 electrons and put them on the inside. 1, 2, 3, 4. Ladies and gentlemen, that's the Lewis structure for water. You have 2 bonds and then 2 pairs of electrons left over. That's it. So we have 2 bonds. So if I want to, I have 2 single bonds, right? And then I have 2 lone pair of electrons, which we'll get to another day. All right, so here we go. Let's start the next part off. All right, so the next thing we're going to be talking about is ammonia. Ammonia is NH3. All right, so let's take a look at NH3. Now, if you'd like to, why don't you go through and practice this on your own? Number 1, count the total number of valence electrons. Well, nitrogen has 1, whoops, a little bit too big there. Nitrogen has, let's see, 1, 2, 3, 4, 5. Nitrogen has 5 valence electrons. Hydrogen has 1 valence electron, but there's 3 of them. So how many valence electrons total do we have? 8 valence electrons. Now let's draw the skeleton. Which do you think is going to go in the middle? The nitrogen or the hydrogens, which are not allowed to go in the middle? That's right, the nitrogen is going to go in the middle. So I'll draw my nitrogen, and then I'm going to bond the 3 hydrogens to it. 1, 2, 3. And now we look and we say, okay, well, I've counted the number of valence. I drew the skeleton. Let's we get 8 electrons to use total. We've already used how many electrons in the bonds? Remember, each bond gets 2 electrons. So how many electrons have we used? That's right, we've used up 6 bonded electrons, which means how many electrons do we have left over to use? We have 8 to use, we've used up 6, that's right, now we have 2 electrons to distribute. Always distribute to the outside first, but hydrogen already has all of its electrons because hydrogen needs 2 electrons. It's got 2 electrons, 2 electrons, 2 electrons, right? So we distribute on the outside if we can, but since there's no room, we're going to distribute to the inside. 1, 2, we're done. This is the Lewis dot structure for ammonia. An N with 3 bonded hydrogens and then a lone pair on top. Again, 8 valence electrons total, minus 6 electrons from the bonds, and finally 2 electrons to distribute. Now, if you want to, you can stop the video, and why don't you try out CF4 by yourself, or do it with me. Just to review, all atoms want to have 8 valence electrons, except for hydrogen only wants to have 2. There are no hydrogens here, which means that everything's going to need electrons here. So let's take a look. Well, it should be number 1. Hold on here. What's going on? All right, so now let's take a look at CF4. Again, try this one by yourself if you want to. Number 1, count the number of valence electrons total. Carbon, let's see. We've got 1, 2, 3, 4 valence electrons for carbon. Okay. Plus, how many valence electrons? Let's see, 4, 5, 6, 7. Fluorine has 7 valence electrons, but there's 4 fluorines. So what's 7 times 4? That's right, 7 times 4 equals 28. So what's the total number of valence electrons? There are 32 valence electrons. After we get the total number of valence electrons, we draw the skeleton. That's going to be a carbon. And the carbon is going to go in the middle because it's the one that's most different. Matter of fact, let me delete that and start that again. So which of these elements are going to go in the middle? Will the carbon or the fluorine go in the middle? That's right, the carbon, because the carbon is most different. So we're going to put a carbon and we're going to bond the 4 fluorines to it. 1, 2, 3, 4. And then we're going to look at our rules. So we've drawn the skeleton. We've counted the total number of valence electrons. We get to use 32 valence electrons total in this Lewis structure. How many of those 32 electrons have we used? Well, these are the bonded electrons where it says subtract out the bonded electrons. How many electrons have we used in the bonds so far? That's right, we've used 8 bonded electrons. So we're going to subtract out the bonded electrons, and that's going to leave us the number of electrons we get. So what's 32 minus 8? It's going to be 24 electrons to distribute. So we're going to distribute those electrons. But where do we distribute the electrons? It says distribute the electrons, but start on the outside. Each one of these fluorine have 2 electrons. Fluorine wants to have a total of 8 electrons because it's not hydrogen. Remember, everything pretty much wants to have 8 except for hydrogen. So we start adding them in until we add up to 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. But you probably already recognize that each one of these fluorine needs 6 electrons, and 6 times 4 equals 24. And yes, it'll work out perfectly every single time. Okay, so that is how we work these out. Now, my suggestion is that you sit and work some of these out. Okay, so, but now let's get down to the nitty gritty. All right, so bigger atoms, ladies and gentlemen, can hold more than 8 valence electrons. Oh my gosh, Mr. Pepik, you've talked so much about the octet and everything wanting 8 electrons, and now you're telling me they can use more? Yeah, that's what I'm telling you. So, only a couple though. Phosphorus, sulfur, bromine, or boron. This says boron. But then, oh, bromine's right here. I was like, bromine should be in there. Bromine and some of these other elements, they can hold more. So sulfur and bromine can hold 8, 10, or 12. Phosphor can hold 8 or 10. Bromine can hold 6 or 8. But I'm not going to hold you to remember all those. You just need to understand that if there's an opportunity, more than 8 electrons can be had. So let's do the Lewis dot structure again. Okay, so let's take a couple of looks at these rules again for drawing Lewis dot structures. Count the number of valence electrons, draw the skeleton, and subtract out electrons you've already used, because you can only use the total number. So let's take a look. Phosphorus. 1, 2, 3, 4, 5. There's phosphorus. So how many valence electrons does phosphorus have? Phosphorus has 5 valence electrons. And we're going to add those valence electrons, because we need the total number, to the number for chlorine. So how many valence electrons does chlorine have? That's right. Chlorine's going to have 7 valence electrons. Well, 5 times 7 equals 35. So there's 7 valence electrons times 5 equals 35 valence electrons, and 35 plus 5 equals 40. So we have 40 valence electrons, right? So we have 40 valence electrons, and now we want to draw the skeleton. Mr. P, where do these go? Well, each one of those chlorines are going to be attached. Well, how do you know that there's 5? Because it says there's a 5 right there. So where do we put the 5th one? You just add it on anywhere. But you must start off with those 4 quadrants. So why not? No, I'll put it over here. All right, and then it's out of the way. So how many electrons valence do we get to use on this whole problem? That's right, we get to use 40. Now, how many electrons have we already used in our bonds? Remember, there's 2 electrons in each bond. That's right, we've used 10. So we're going to subtract out 10 bonded electrons, because we get to use 40. We've already used 10. Mr. P, wait, what? That's okay. You probably missed the previous 10 minutes of this video. Each one of these bonds has 2 electrons. And seeing as there's 5 bonds, 5 times 2 equals 10. All right? So what's 40 minus 10? 40 minus 10 equals 30 electrons to distribute. Now, where do you start distributing? Always on the outside. All right? Chlorine wants 8. It only has 2. So each chlorine is going to need 6 more. And you can probably see that if there's 6, 6, 6, 6, 6, 6 times 5 equals 30. Let's see. 1, 2, 3, 4, 5, 6. Let me pause the video. And then as we finish up these last couple, 1, 2, 3, 4, 5, 6, each one of these chlorine has 8, but this phosphorus has how many valence electrons? 10. Now phosphorus, we say only wants 8, but what do we now know? That some elements can have more. And if this element exists, it must be drawn like this. So let's take a look at the next one we have. Now some of you might go, oh my gosh, there's so much more. Sure there is, but now let's take a look at it. So H2SO4. First thing we do, count the valence electrons. Each hydrogen has 1 valence electron, and there's 2 hydrogens, so there's 2. Sulfur has 6 valence electrons. Sulfur has 6 valence electrons, so there's 1 sulfur. And then each oxygen has how many valence electrons? That's right, each oxygen has 6, but there's 4 oxygens, so how many total valence electrons will these oxygens have? That's right, 24. So let's add all those up. We have 24 plus 6 plus 2 is going to give us 32 valence electrons. Mr. Pevig, how do you draw this? Well, I'm not going to give you one like this that's so complicated for you to draw on your own, because it would be hard for you. But generally speaking, hydrogens are always going to go on the outside, and then the one that's the least, which would be sulfur in this case, is always going to go in the middle, and then you have the 4 oxygens going around the sulfur. So it would look, believe it or not, a little something like this, where you'd have your sulfur is going to be bonded to 4 oxygens, right? And then each oxygen is going to be bonded to that, to each oxygen or hydrogen. So how many bonds do we have total? How many electrons do we have total to use? We have 32 electrons to use. How many electrons have we already used up in the bonding? Good, we've used up 12 electrons. So 12 electrons have already been used up in the bonds, which leaves us how many electrons to distribute? How many? 20. Now, always distribute to the outside first. Well, hydrogen already has 2, so we don't distribute any to the hydrogen. So let's distribute here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, because these oxygens each need 8, right? And then, here we go. Let's see. This oxygen here has how many? 2, 4. So it needs 1, 2, 3, 4 more. So that's 6 plus 6 is 12, plus 4 is 16, plus 2 more equals 20, ladies and gentlemen. So you can see 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We've used up all our electrons, and now we're all set. So ladies and gentlemen, I'm hoping that you have, I'm hoping that you can see how we do this. The video's been going about 20 minutes, and that's it. Just as a quick review, I didn't do it here, even though it asks you in the assignment. How many and what kind of bonds do we have here? That's right, we have 5 single bonds. And what kind of bonds do we have here? Good, we have 6 single bonds here. All right, so at this juncture, ladies and gentlemen, we're all set. Next class, we're gonna kick it up a notch, but this should be a nice review for you because these are all things that you've done before. We're just changing the perspective on it. So have a good time, complete the handout. I'm hoping it goes fast for you. Have a great day. You know what, I was about to stop this video and then I went, let's give the kids one more example. So I apologize. So here we go. So very quickly, let's do one more Lewis dot. We'll do 2 more, okay? So we have sulfur with 3 oxygens attached. So the first thing we do is count the valence electrons. 1, 2, 3, 4, 5, 6. Because there's sulfur. Sulfur has 6 valence electrons. How many valence electrons does oxygen have? There's oxygen right here. Oxygen has 6 valence electrons, but there's 3 of them, right? So how many total electrons are due to the oxygen? That's right, 18. All right, so the total number of valence electrons that we have for this compound is 24 valence electrons. Now, next thing we do is draw the skeleton. What element will go in the middle? The oxygen or the sulfur? That's right, the sulfur, because there's less of them, right? So, and it's further down the periodic table, but that goes back to our last lecture. The ones in the middle are further on the bottom and further to the left, the ones that are less electronegative. So we have sulfur, which is going to go in the middle. Then we're going to bond it to 3 oxygens this time. Now you might be sitting here going, whoa, sulfur, I don't know if sulfur is going to have enough. Well, let's just take a look at that. Let's see. How many electrons did we already use in the bonds? As it says, count, draw, subtract the bonded. Remember, there's 1, 2, 3, 4, 5, 6. So we've already used 6 electrons. So minus 6 bonded electrons leaves us with 18. So here we go. 1, 2, let me make them bigger. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Are all of the oxygens happy? Yes, all the oxygens have 8. Is the sulfur happy? No, the sulfur is not happy. Why? Because this sulfur only has 6 electrons and the sulfur needs to have a minimum of 8 electrons. So what's going to have to happen? Something that we did before, right? The oxygen is going to have to share the electrons. So the oxygen is going to share 2 of those electrons. We're physically going to erase 2 of those electrons. And those electrons are going to be bonded, ladies and gentlemen. Whoops, right here. Whoops. The electrons are going to be bonded and form another bond. Does it matter which set of electrons we use? Nope. But just as long as sulfur gets 8 electrons total. So this oxygen still has 8, that oxygen still has 8, and then 1, 2, 3, 4, 5, 6, 7, 8 electrons for that oxygen. So what do we have for bonds? Well, how many single bonds do we have? That's right, we have 2 single bonds. And do we have any double bonds? Yes, we have 1 double bond. That's the double bond right here. 1 double bond. So let's take a look here. Let's do one more example. BH3, ladies and gentlemen. All right, BH3. At the very beginning of this video, we showed you there are some exceptions to the octet rule. Phosphorus, sulfur, and bromine can have more. Boron, which is this element right here, well, that's probably not the best size I could have used. Boron right here is the only element that you're going to come in contact with that can have less than 8 elements, and less than 8 electrons. Boron has the ability to only have 6. All right, so what I'm going to do is I'm going to take you to that right now, and we'll do that example, and then I'll let you go. Oh, where are we? There we are, BH3. So let's just draw this one out. How many valence electrons does boron have? That's right, there's 3. And then each hydrogen has how many valence electrons? 1. And there's 3 of those hydrogens. So that's going to be 3 plus 3 equals 6 valence electrons total. Now we're going to draw our skeleton. There's 1, 2, 3. And we're going to put our H's on here. A lot of sticks, ladies and gentlemen. How many electrons have we used? 1, 2, 3, 4, 5, 6. So we've used up 6 electrons. So there's 6 bonded electrons, which leaves 0 electrons to distribute, which means this is our Lewis dot structure. There's no extra electrons sitting around. All right, what do we have? 1, 2, 3 single bonds. That's it. All right, kids, I'm going to wrap it up now. Have yourselves a great day, and I'm right here for any help that you need.